Hi, my name is Mostafa Monsour. I'm a solution architect at Nuage Networks. In this video, I'm going to show you a demo on application-aware routing. Application-aware routing is one of the many features that Nuage offers as part of Nuage SD-WAN solution. Application-aware routing consists of three functions. Application discovery, which is a DPI engine that classifies network applications as they come to the Nuage router. We classify applications based on their layer 7 signature or based on a 5-tuple flow information that the customer defines. Application discovery gives you a full view of all the applications that are running in your network, including the bandwidth that they are consuming and the WAN path that they are taking. Second component is the network performance measurement, which gives you a real-time view of the performance of your network, such as packet loss, delay, and jitter. Third component is the application SLA's traffic steering, which leverages the previous two features and enables application flows to be switched to another WAN uplink if the network performance of the current WAN uplink degrades beyond the SLA thresholds that you specify in the application policy. Okay, now let's take a look at the demo topology. In this example, I have two branches. Each branch has a Nuage NSG router, which is connected to two different networks, one WAN uplink connected to MPLS network, and another WAN uplink connected to the internet. I will create two video streams from the same source going to the same destination. The sender will sit behind NSG 1 and the receiver will sit behind NSG 2. Initially, these two video streams will take the same path. However, I will configure one of the videos to be routed based on the application SLA, and the other video stream will be routed based on the traditional routing methods, which is IP destination-based routing. Then I will introduce some network jitter to simulate a link brownout. This jitter will violate the SLA for the first video and will force video 1 to switch to the internet link, since it has better SLA metric. The second video though will stay on the MPLS link since it doesn't have any SLA associated with it. Now let's go to the Nuage GUI and start the configuration. So this is the Nuage VSD GUI. The first step in the configuration is to configure a network probe. The network probe will basically measure and report the performance of your network in real time. We'll click on the plus sign at the bottom of the screen to start configuring this network probe. We'll give it a name, fast probe, and then we'll assign a QS setting. Usually you assign a QS setting that's similar to your application. Then we'll type a value for the payload size of that network probe. You can have a value of 64 bytes or you can have a jumbo frame. You specify whatever value you want, and usually it's similar to the application. Then last option here is to put the interval time. How often do you want to send the probe? Do you want to send it like one probe every 10 seconds, or do you want to send like 10 probes every second? This will affect the convergence time, like how fast your network will converge from one link to another link. In case of a brownout or a link failure, I will go with a fast convergence, so I will assign 10 probes every second. Next, I'm going to go and create a new application. So I will go to the application section on the left side. I'll click on the plus sign, and then we'll give a name for the app. We'll call it video 1. We'll give a description. And if you want to select an app based on an application signature, you can do that by clicking on the application signature box and choose one of the 1400 apps that we support. For example, you can search for Google and you will find like Google search engine, Google Apps, calendar, desktop, etc. In this demo, I'm going with a custom app, so I will choose a protocol of UDP and a destination port number of 10001. This will be the port number used in the VLC video. I will leave the rest of the fields with the default values, but you can change the values. For example, you can make either type either v4 or v6. You can change the DSP value for your app. You can also pin specific applications to certain uplinks. For example, you can say that I want my critical business apps to go through the MPLS link, but Facebook and Google, they can go through the internet link. To associate SLA with an application, I will click on the Enable Performance Management box. This will allow me to put values for the packet loss, for packet delay, and packet jitter. For packet loss, I will put 5%. For packet delay, I will put 200 milliseconds, and packet jitter, I will put 30 milliseconds. In case there are multiple compliant paths that satisfy your application SLA, then you can select the best path among them by clicking on the Optimize for option that you see on the screen. Last option is the monitor type. It means when do you want to start monitoring the network SLA. You can choose first packet. This means once application is classified, SLA probes will be sent to measure and monitor the network performance. Continuous means send the probes before you identify the application. So when the application comes, you are already aware of the network performance and you know what's the best path for your app. First packet and continuous basically combines the previous features. It will start sending the probes as soon as it identifies the application, and then it will keep sending the probes on all uplinks even if the application is terminated. Now I'm going to click on the create button so we can create this video stream with the SLA. Next, I will click on the plus sign to create the second video stream. I will give it the same configuration, except that this time it will be a different destination port and no SLA. Okay, so now we have the two video streams created. The next step is to associate the probe to the video streams. We will do that by creating an APM group. APM is basically an application performance management group. It's a group of multiple applications. It allows you to bundle multiple applications together and associate them with a probe instead of assigning an individual probe to each application. So we're going to click on the plus sign to create a new APM group. We will give it a name. Then I'm going to select the probe that we previously created. Now I will add the Video 1 application to the APM group. This will associate our probe to this specific video. Next is to create another APM without any probes and add Video 2 to the second APM. I will not choose any probes for this APM group and I will click Create. Now I will add the second video application to this APM group. Last step in the configuration is to add the two APM groups to a Nuage domain. The Nuage domain is the overlay network, and all the NSGs that are running in this overlay will get the configuration that we just did. In this example, our domain has two branches. Each branch has an NSG router. We will click on the application group icon to add the APM groups to this domain. Now we have the APM groups added to the domain. Next step is to go to our VMs and start sending the video streams. VM1 in this domain is our video sender, and it sits behind NSG1 in branch 1. VM2 in this domain is our video receiver, and it sits behind NSG2 in branch 2. Now let's go to VM1 and start sending the two video streams. I will open VLC and select the video file. I will choose the UDP protocol. I will put the IP address of VM2. This is my receiving end, and the port number of 10,001. The first video stream will use 10,001 and the second video stream will use 10,002. Then I will click next. Then I will click stream and the video is running. Now I'm going to start the second stream. Same configuration like the previous video, except with the port number. This time it's going to be 10,002 instead of 10,001. Now I'm going to jump to VM2, the receiving side of the video. I will open two VLC instances, one instance for each video. For the first VLC video, I will choose a port of 10,001. And for the second VLC video, I will choose a port of 10,002. Now we are receiving the two videos, so let's jump back to the VSD and start looking at the stats. This is the application group for video 2 the video that doesn't have SLA. If I click on the stats icon, I can see the flow information for video 2. For example, the source energy, the destination energy, the port numbers, which port it used, is it the primary or secondary, and how much bandwidth did it consume. I can also go to the second APM group and I will see the same information. The only difference is the destination port will be 10,001 instead of 10,002. You can also see the same information displayed in different chart types. For example, instead of having a table, you can go to the enterprise stats and you can see the top apps represented in a pie chart or in a graph. Okay, now let's go back to the VM and start introducing some delay and jitter in the WAN link. Here on the right side of the screen, I have a WAN simulator, and on the left side of the screen, I have the VM with the two videos. To introduce jitter and delay, I will use the Linux traffic control command. It basically emulates a brown link by adding a delay of 100 milliseconds and a jitter of 50 milliseconds. Once I finish typing the command, you start noticing that both videos are experiencing some issues. The video on the right side though will correct itself in a second or less and will move to the second uplink that has good SLA, while the video on the left side will stay on the bad link and the screen will be scrambled. This concludes the demo. For more information on Nuage SD-WAN solution, please check our website at nuagenetworks.net/VNS or follow us on Twitter at Nuage Networks. Thank you for watching.